So KIN Center for Digital Innovation is a research center here at the School of Business and Economics. And our aim is to study digital innovation by working together with practice. So it's not that we are only doing applied research, we're doing academic research, we write in these journals that no one reads, but we also write blogs and we work a lot with the companies themselves. So some of the topics that we study managing digital innovation. So we look at ecosystems, we look at platforms, how this innovation process is different when you talk about digital technologies. We look at the design and use of digital innovation. So we look at the changing professions, the change of work, change of organizations. We look at the new IT function. So IT is different nowadays. Now we talk about digital technologies. And we're looking at all these new digital tools. So we look at AI, we look at data analytics platforms, crowdsourcing, blockchain, maybe also the quantum computer, if that is something that will develop, but we don't think so. So we are socially responsible. That's something that we think is very important to emphasize. So we want to be multidisciplinary. We want to go beyond the hype. We want to be different than the consultants. We want to show what is really going on. And we're not only looking at the implications for management, but we also look at the implications for the workers themselves, for the ecosystem. So therefore we say we are inclusive. And our research is mainly qualitative. And when we go into the field, as we call it embedded research, we're doing process research. So we are embedded, we walk with the people who are developing systems or using systems, and we study it for over 1 or 2 years. And we try to create impact. I say we try to create impact because we're still not there yet, but there is some impact. We do master classes, we do exec education, and we do all kinds of seminars, and this KINTalk is an example of creating impact. Sorry, I'm just walking on. We have actually 3 themes in our research group. So the KIN research group has already, I think, more than 40 people, including PhD students, studying digital technologies. We look at organizing for digital innovation, we look at the future of work, and we look at data-driven innovation. So these are the themes, but of course they're very much overlapping. We also, to reach out and to make impact, we also have a business network. So for companies here present, maybe there are companies present, we want to work, and we already do that with companies by, for example, involving them in our network and sharing our expertise with them. We also have an exec education that starts in the fall, which is now, I think, on digital innovation and transformation. So if you're interested in that, you can also reach out. We have a conference on AI work, and I am also involved in that. There's several people here as well. And it's a multi-stakeholder conference. So it's not only academics, it's also business, it's also consultants, it's also policymakers, it's also the press. Everyone is there. It's also not only business administration, it's also law, it's computer science, it's everyone. Check the website. You can already see the keynotes, some of the keynote speakers. It really will be a great event. I think it will be here at the Zuidas. All right. So I will briefly say something about artificial intelligence at work. That is one of the themes of our KIN group. We have, as we call it, an AI work lab with, I think, already 11 researchers sitting here also, across everyone, studying AI at work. And I want to tell you a little bit about that. And we think that we have found a very important niche in this whole discussion about AI. And the niche is that we in the group are all studying AI at work. So what does it mean when AI is really developed and really used in practice? So we're not going with the flow and talking about that AI will take over jobs or that AI will change the whole world. We just go to organizations and we study it. So there are several perspectives on AI at work in organizations, and I will briefly go into that. And I will come to our perspective, and we call that the socio-technical perspective on AI. But the first perspective is probably the most known perspective, and that is the labor perspective. And it basically has two views. It's a labor economics perspective and the skills perspective. And these people studying that, and it's actually quite a large group of people, they study whether and how AI is changing work and professions in organizations. And they say most of the times that there will be a big change, a lot of jobs will be taken over, and maybe all our jobs will be taken over, and we will come to a new economy. And there are quite a lot of books on that. These are very nice airplane books, as we call that. You read it and you think, oh, shit, my job won't be there anymore. I need to hurry up and be a data scientist because that's the new job in the future. But what these books and these researchers don't do is go into the field and study what is really happening. And that is something also that Lauren will discuss. If you go into the field, for example, go to the police, you see that things are completely different than we expect it to be. Another perspective is the critical perspective, also very dominant. Of course, this perspective is important. It shows that, oftentimes the data that is used in AI is dirty, so garbage in, garbage out. It's a lot of profiling is happening, for example, with HR analytics. In the case of AI, specifically machine learning, a lot of our knowledge is black box, and you have so many of these books and articles that create a sort of fear around AI. So people are getting scared about AI. It's not only taking over our jobs, but it's also a sort of totalitarian regime that is taking over society. There's a lot of discussion about responsible AI also. Again, they create fear, but they mainly focus on the big tech companies, the Amazons, the Facebook, well, you know them, Google, and they're probably right because these are big companies, but they're not really studying what all these smaller startups and scale-ups are doing, and we have a lot of them out there. So again, it's very important to study what is happening in practice. What are these small AI firms really doing? For example, with designing systems, and do they include ethics in it? And then there is this business perspective, of course, dominated by the consultancy organizations, Accentures, McKinsey's. They write reports. They're much more optimistic. It will be AI will change organizations. It will change our business models. It creates optimism. So if you read that in the plane, you feel really excited. So we just had the AI summit. Some of you have been there in Zaandam. A lot of companies, right? I heard, I wasn't there, I should have been there, but I wasn't there. But I heard from people that it was quite commercial. It was a business and strategy perspective. So not really about what is really happening in the field. And that is our perspective. I wanted to talk also about the bridges, but I only have 1 minute. So very briefly, the socio-technical perspective, or whatever you want to call it, focuses on both the design, implementation, and use of AI in real practice. So what we do in our group, we go to an organization, we talk to data scientists, we talk to the developers, we also are part of the group, and we study how these systems are designed, because we think you can only say something about the implications of AI if you know how these systems are, when you know how these systems are developed, and what kind of knowledge is inscripted in the system, and what kind of ethical values also. So we try to avoid the fear, we try to avoid the myths, we try to avoid the hypes, and we just study it. We're trying to be objective. So this is we call it the AI Work Lab at KIN. Yeah, so these are examples of, for example, Bomi Kim. Yes, their PhD student, she's studying how radiologists are using AI in practice and how these systems are designed. Elmira is studying AI for recruitment practices, studying how these systems are designed, specifically also looking at ethical values, of course, and how they are designed in the system. We will do another KINTalk about that. And this is an image of hot spots and hot times of the predictive policing case. So I think this was my introduction of what we're doing. It was very brief, and I will give the floor to you.
My name is Willems. I'm a data scientist and I'm working for the Dutch National Police. I'm going to talk a bit about the crime anticipation system. It's one of the first initiatives that we did as data scientists at the Dutch National Police. And that's why it's also kind of interesting to talk about it, because of course I'm going to tell you a little bit about how it works, but it's also kind of interesting to see how it's rooted in the organization. Because we started doing this in about 2012, so that's about 7, almost 8 years ago. And it was quite a challenge to get people to actually use it, to convince people that it's a good idea to use this machine learning technology that we basically never saw before. So the question that was posed to me when I entered the service of the police was a very general one. Basically, what should we do with our manpower? Probably you've all seen a police movie or two. Usually what you see is like you see a police station, and then at the wall you see this map, pinned to the wall. Everywhere the type of crime that they are fighting happens, they put another pin in the map, right? So you get this dotted map, and basically you can see where the problem is worse because the most pins are there. Of course, that's pretty old-fashioned, so what we're doing now is basically we're using computer screens to do that. You can see an example of that there. That's a so-called heat map. Basically, that's a lot of dots with a filter overlaid, and basically where the color is most deep red, that's where the problem is worst. It doesn't really help us to the extent that we would want it to help us, because it turns out that basically an analyst can make this map look the way he wants it to look. Right. So, for example, if you have an analyst who says, well, from my experience, I know that this area right here is the usual problem spot, so I'm just going to use like 2 years of data so that the area pops up. Well, another analyst might say, well, I've been tracking this problem for a while now, and I think this area is popping up right now, so I'm not going to use quite as much data to make this one pop out best. Right? And they might both be right, but you can't really tell in advance from those maps. So that's why we started using predictive technology, right? Because basically you can, using machine learning models, you can say with the data that we have today, where the hotspots are going to pop up in the coming week. That's basically what we do. So how do we do that? We divide an area, so that could be a team, a district, or a police unit, in square areas. Basically, the police is organized in a geographical manner, right? So you have your units. For example, Amsterdam is a police unit. Then you have your districts. I think we're in District South here. And then you have your teams. For example, Team Buitenveldert. That's where we are now. So we divide the area into square areas. We collect data on these areas, and then we build a classifier. So, what kind of data are we collecting? We collect two kinds of data, namely location-specific characteristics and the crime history of that area. So those location-specific characteristics are basically bits of data that don't vary so much over time. For example, we have our data from the Central Bureau of Statistics, our demographics and our socioeconomical variables, so that we know, for example, how old the occupants of a square are. Well, you can expect them to be, how many men, how many women, that kind of stuff. We also can guess a little bit about how much money is being made on average in those squares, for example. We also have some information about known suspects, because it turns out that especially in Amsterdam, not so much in the rural areas, but in Amsterdam, some burglars have a preference of working close to where they live, right? So they don't like to travel very far. So if you know that there's a big number of burglars in a certain area, that says something about the probability of a burglary occurring near or in that area. So that's why we also have a couple of distance measures, like the distance to the closest known suspect, and also the number of known suspects within 500 meters of the center of that square. Apart from that, we also look at the crime history, and basically you have to think about the number of crimes that are occurring in certain time windows with respect to when you are generating the maps. So, for example, the number of crimes last week, or the week before, or the week before that. We do that until 12 weeks ago. So basically, if we make a map, we consider what happened in a square up until 12 weeks ago. We don't only look at what happened within the square itself, but also what happened in the squares that are adjacent to that square. Because it might be that in the square that I'm looking at, nothing is happening, and nothing has happened for quite some time. But in the neighboring squares, crime might pop up, so you could get some kind of contamination effect. And we also want to take that into account, and that's why we're also looking at those neighboring squares. Okay, so this is basically, very high-level explanation of how this data set is put together. So what we're doing now is we're going to build a classifier, and the purpose of that classifier is, of course, to get some optimal selection rules for high-risk squares. So with the data that we know now, at this moment, we want to select a couple of squares that we think are going to be high in risk, so that we can try to do something to prevent those crimes from actually occurring. So you have a lot of techniques to build classification models with. I tried a bunch, and I ended up with logistic regression as the best one. And the result is then a model that, with which you can compute the likelihood of future crime using the currently known data, as we set out to do. So how well does it work? Well, you can use this model to identify like the 3% highest risk areas. This is a team in Amsterdam. It's called Nieuw Noord. It's well known as as a burglary haven, or a haven for burglars, I should say. And we colored the top 3% of areas. So these are the actual burglaries that happened within a certain week, 25. And as you can see, some of these burglaries took place exactly in the squares that were predicted, and another bunch didn't. But let's delve a little bit deeper. So 5 burglaries were predicted. So 5 out of 25. So that's 20%. So 20% of burglaries took place in 3% of the area of this basic team that we predicted in advance. That's not too bad, but also not very impressive. But we have some other observations, and that is that a certain type of misses are pretty close to the areas that we predicted. That's another 30%. So together, that's about 50%. So this is a pretty good example. It doesn't always pan out like that. It kind of depends on the crime dynamic in the area, and also kind of the size of the area. But this is not bad anyway. So now the biggest obstacle of this entire process, I'm going to skip this one. It's interesting, but I'm going to skip it anyway because I don't have so much time anymore. That's more about how we use it. Because if you only show these maps to cops, they probably will ignore it, because they're not really tech savvy, and they might want to try it out for a week or so, but they don't really want to change their daily work based on maps. It's just not in their personalities. So what we do is we incorporated these maps in the preparation of the services. of the surveillances that we do. So we produce the maps, and then we make these available to local information specialists. So every police team has a couple of information specialists. And it's their job to enhance that information that we offer, that where and when information that we offer with the maps, with qualitative local knowledge. So they might recognize some squares because that's like a hangout spot of a local gang or something, right? And in that way they produce intelligence. So they make a little document that basically describes their findings and also their hypotheses, and a little bit about what the police could do to counteract what they think is the underlying problem of that high risk. Based on that, we plan activities and then we carry out those activities. And it looks a little bit like this. So you have your area and your time interval, and basically you have a little bit of advice. It might be extra surveillances and then with some extra advice. So in this case they say, okay, look at the fire corridors that don't have alley fencing, right? So apparently this information specialist observed that that's a route that burglars are likely to take. They also notice a couple of other things. So which says, well, there's been recently two suspect situations, 3 guys on 2 scooters who were checking out buildings, right? So that's something interesting that probably your machine learning algorithm would never really notice. So it's kind of interesting to bring those two information sources together. So you have your quantitative information that comes from the system, but you also have your qualitative information. It's basically in the heads of the information specialist and especially and actually everybody in the team, right? Now that's also kind of a nice source for intelligence if you want to actually solve a problem in an information directed way, right? So it's kind of interesting for a local information specialist to actually build up a good relationship with the community police officer, because, well, not everything that the community police officer knows ends up in the system, so you can't really access it that easily, right? But if you call them up every week, say, hey, I think there's a hotspot here, I've seen that they use a certain modus operandi, what do you think is going on here? You might have some very interesting hypotheses that are of great interest if you, for example, want to plan a surveillance or something like that, right? So by using these kinds of technologies, you kind of change the entire information cycle, and that allows you to build up a way better information position. That's not the direct result of the system itself, but more the result of working with the system. So that's quite nice to see.
For 3 years I've spent almost full time with the Dutch police. First 2 years within the police office itself, studying, as Dick says, the information specialist. Well, I termed them the intelligence officer. That's the academic freedom you have there. So if I talk about intelligence officers, we're talking about the same thing. So that was the first 2 years, and after that I spent a full year full-time with the police officers in the street, seeing what their work means and what these kind of technologies means for their work and how it changes because of it. So that is what I will talk about now, to combine kind of Marleen's introduction on how we actually do research and the phenomenon that Dick has been talking about and has given us so much information about. So, to start this, I want to focus on 3 common assumptions around AI, because I think that if you look at the common debate that is going on around AI, you see 3 main themes. First of all, a lot of the debates are about the individual and the individual effects of AI. Then there's a lot of questions, and Marleen already referred to it, about job loss, about de-skilling. And finally, the third point is that it's said that AI leads to more efficient and objective work. I want to unpack these 3 assumptions by using the example of the police. So, to kind of recap what predictive policing actually meant, it means a graph and a map. it means hot times and hot spots. The graph is for the times. The map is for the area where the chances of the crimes are highest. I don't know whether anyone is living in the area of Artis.
Yeah.
So the move, no. But there's a graph and a map, and as Dick already indicated, there's a difference between the output of the algorithm and actual police work. So the question around my whole research was, how is predictive policing actually used in practice? Because there's such a space between the two. And if you look at that, you come to this. And that is kind of the empirical academic output of having spent 3 years in the field. That's the circle. But then this is actually an answer to the first point and the first assumption that I just referred to, that the outcomes of the use of AI are mainly focused on the individual. But what you see here is that it's actually a network of actors. We put it in a circle, but there are many people influencing the use of this technology. So it's not only Dick who makes the algorithm, it's also the intelligence officers who make it useful for the police officers. It's the police management who actually needs to accept this technology, and it's the police officers who need to use the technology but also make the data for it. So together they can kind of make a success out of this technology, but on their own they're not doing anything. So if we talk about the success, so let's start with a good story. If you talk about the success, well, this is a success. Yeah, this is a success. Well, the picture maybe not, but the story around it is a success. Because in December last year, the district where I studied predictive policing received a national award because they had the highest degrees in burglary over the year of all of the Netherlands. And that decrease was not 3%, that decrease was 47%. So that it's quite a high decrease. That's why they received this awesome award and had this beautiful picture with don't even know his name. Of course, and I think that there will be some questions about this also after this when we have our expert panel. Of course, there are many reasons, can be many reasons for this. But because they have invested so much in burglaries with this technology, you can assume that that's linked to it. So that's first. But then, I also want to focus on the intelligence officers or the information specialists, as Jay and Dick just talked about them, because there are two stories around them. And that's the second point that I also want to point out first, because we're all talking about job loss and de-skilling of people because of the use of AI, but actually these intelligence officers are a great example of reskilling because of AI. Because these intelligence officers were within the police before they started to use the system, but they were, well, quite insignificant actually. Some people refer to them as a shelter. I don't know whether you want to be referred to that in that way, but they weren't very influential in police work. But over time and over the time of using this system, they became more and more influential and useful for police work. Because what they did, and that is what Dick already kind of showed, is they make it useful for police officers. So this is an intelligence officer, this is a police officer, and here the intelligence officer is actually explaining the output of the algorithm to one of the police officers. What do you need to do to make sure that this works, or to make sure that you go there? But, and there I'm also an academic, so I can also be critical, because what these intelligence officers also do is that they transform the output of this algorithm. So they don't only show, like, this is what the algorithm produced, please go and do it. But what they do is they select certain times. They select certain areas where they need to go. And sometimes they add people to it. While Dick purposefully didn't include people. So if you talk about the third point, artificial intelligence is making work more objective. It depends on what you look at, because these people have all the freedom to include their own subjective choices. So this is a very important point. If you go into the field and observe how they are actually using it, you see that it's not the technology necessarily that is more subjective, it's the people that do stuff to it. Finally, there's also a question around this AI is making work more efficient. Because there is a reason why why COS works. That is because there's data. There's data about the criminality that's going on. But if you look at this type of organization, where the data comes from most of the time is the police officers themselves. So while we want to see them actually like this, and this is actually a cool story, for those who are Dutch, Google Agent Bart Brandt, and you'll see the story around this, very cool. But we want to see police officers like this, but what we see more and more is police officers like this. So while this technology is used or implemented to have police officers outside in the field making sure they do their job, increasingly they have to also report their work. And that's not only because of cost, that's because of the whole movement towards data-driven policing. So what you see, and that's what I want to, I'm not only showing pictures here, again pictures, but a bit of evidence as well. Because what you see here, over this year that I spent the time with them, I mapped out and I tracked what they did during a shift. And the gray areas are the areas that they spent the time behind their computer reporting what they did, making the data. So on average here, they spent about 4 hours of the 8 hours that they are in the field making data. That means that they're not outside. Going back to this circle, with all the people involved, we see the counterfactuals of the assumptions that I just mentioned. First of all, I want to highlight that we need to have a shift in focus from an individual perspective of AI towards a more embedded perspective of all these actors that have an influence on the technology. Next to that, I want to really emphasize that we're not only talking about de-skilling and job loss, but we're also talking about reskilling. But finally, we're not necessarily talking about more objective and efficient work. Because what I showed you, making this artificial intelligence meaningful for work also means including subjective decisions. And what I would like to propose then is that we're not only talking about, as a lot of governmental agencies are now talking about, regulating AI. I would like to propose that we're not only regulating AI, but we need to think of how to regulate the use of AI. So the people who are actually using it. And next to that, using AI requires data making, so we need to take into account the people who are making the data. How is that influencing their work?